So let's go over normal distribution, meaning missing mean or standard deviation worksheet. If you see here, we're going to use our calculator quite a bit, so make sure it's in the ready. Number 1, the weights of players in a sports league are normally distributed with a mean of 76.6 kilograms. Correct to 3 sig figs. It is known that 80% of players have weights between 68 kilograms and 82 kilograms. The probability that a player weighs less than 68 kilograms is 0.05. So, lots going on there. So let's start with the first one. Find probability that a player weighs more than 82 kilograms. So let's draw this out. So something like that. Not my best, but better than normal. We know that a probability that a player weighs less than 68 kilograms is 5%. So remember, less than starts on the left-hand side. So we go 5% from the left-hand side. That's 0.05. We know that is 68. What else do we know? 80% of players have weights between 68 and 82. So here's 68. If we add 80% to that, we'll get to like over here-ish, right? Like this is 0.8. I don't know how to draw it like that maybe. Try a little different shading. Right, all this middle part is 0.8. And then that gets us to 82. So the question is, find probability that a player weighs more than 82 grams. So what's over here? Well, it's like what's left. Remember how much a full normal distribution is how much? 100%. 1 or 100%. So we just have to subtract off all this stuff here. So 1 minus 0.8 minus 0.05, and you're going to get 0.15. That's how much this guy is. This is what they're asking for. Right, so keep in mind, a normal distribution is always 100%. So if I know this is 5%, I know the middle is at 0.8%, 80%, then I can figure out what's left over for the last part, which is what this is asking for. So 15% is that part. Find the standard deviation of weights of players. So if you notice, they gave us the mean. Well, first of all, notice how they told us it's normal distribution. So we know it's a normal problem. They gave us the mean, but they did not give us a standard deviation. Remember what I always say with that? If they don't give you, if you're missing one of these two things, I don't care if you're missing the mean or standard deviation, you have to use this formula, the Z formula, the normalization formula. This is a key to find anything that's missing. So if you're missing a mean or standard deviation, you have to use this formula to find it. And another thing with that, the Z here, what is Z? That's always the same thing. It's invert normal. With the fact that it's Z means it's the standard normal, which is the 0, 1, 1. So it's invert normal, whatever area, 0, 1. That's what the Z stands for. Z is for standard normal, which is when you use 0 and 1 for the mean and standard deviation. So just to recap, right? Anytime you're missing either the mean or in this case the standard deviation, you have to use this formula to get it back. Your Z is always the exact same thing. It's always the invert normal, whatever area we're doing. And then mean is 0, Z is 1, and standard deviation is 1. That's what the Z stands for. For that. Okay, let's plug in what we know. So you gotta find something we know. We know the mean 76.6. So I could go here. That's the mean. We're looking for the standard deviation. We're looking for the bottom one here. What's my X? I need one thing I know. So let's use this one. The one right here. We know the probability that your X is less than 68 is 0.05. That's what that says. This says the odds you weigh less than 68 is 0.05. That's what goes in here. My X is 68. And my probability or my area is 0.05. That goes in here. So like that. Now all you have is an equation. That's an ugly 5. Slightly better 5. So now we have an equation. I have invert normal 0.0501 for my Z. It equals 68 minus 76.6 over standard deviation. So let's put this in our calculator. So second distribution, invert normal, 0.0501, because that's the standard, they all have it already. And I get negative 0.64885. Now my paper, I'm going to write this negative 0.6448 probably, 9. But I'm going to leave this answer there until I get to my final answer. You don't want to round it to 3 sig figs until you get your actual answer. You want to use your answer from your calculator. So here I have negative 1.64485 equals 68 minus 76.6 over phi. I should do some math here. So 68 minus 76, that's be negative. Well, first, we could get rid of the theta. Right, I have an ugly fraction here. Let's get rid of the fraction first. Let's multiply both sides by by that, and I get negative 64485 sigma equals 68 minus 76 is negative 8.6. Like that, and then we just got to divide by this. So if I do that, if I do negative 8.6 divided by negative 1.6 blah blah blah, I get my standard deviation equals, and here I could round it once I get my answer. So I'm gonna leave that answer there. I'm gonna do this to make sure 78 minus 76.6. It wouldn't be the first time I mess up a subtraction problem. Okay, I feel better about myself. And then you divide it by the answer, the inverse normal value. Again, you want to keep those answers from the thing. So now here I could round. It's going to be 5.23. So you only want to round when you get to the final part of that, the final question here. So answering B, then I can round it. 0.523 is my answer. So I have 0.5226 or something like that. So 0.523. 5.23 I should say. So this is my standard deviation. And then look what happens next. Find probability that a player weighs less than 70 kilograms. Now, we've gone through 3 types of normal problems. There's just a straight out normal CDF problem. There's an invert normal problem. And the one we just did when you're missing a standard deviation or a mean or both. So there's 3 types of problems. You got to know which one's which. This one says find the probability that a player weighs less than 70 kilograms. That's the very first one. That's a normal CDF problem. There's no probability. I don't have to invert. I just got to go, hey, what's the odds you're less than 70? This is the one I like to draw. So I like to draw it. So here's this. My mean is 76.6. That's from right there. I know my standard deviation now is 5.23, and I'm going to use that value. And I want to be less than 70. So here's 76. 70 should be on this side, and I want to be less than it. So here's 70, and you want to be less than it. So we're going to do a normal CDF. Negative E99, right? Negative infinity, essentially, to 70. To my mean is 76.6. My standard deviation is 5.23 from above. Again, I'm gonna use that value now from now on. Now instead of the problem, I can use the rounded version of it. That was an 8 up there. Okay. So now let's do this one. Second distribution, normal CDF. Negative 99, how nice, I already have that for us. 70, and then, come on, 76.6, and then 5.23. Hit paste, and I get my answer. Now again, since I'm doing final answer here, I can just round it. So 0.103. So there we go. It's about 10% chance. Next question. Find the mean and standard deviation. So this one's missing both of them. Find the mean and standard deviation of a normally distributed random variable x if the probability that you're less than 10 is 0.2, the probability you're greater than 13 is 0.15. So I'm missing both of them, so I gotta do 2 of these equations. Because anytime you're missing one, you do this equation. Oops, it's x. And since I'm missing 2, I'm gonna do it twice. Okay, let's do this one in green. So the probability that you're less than 10 is 0.2. So we have to plug that in. So the 10 is your x. I don't know mu and I don't know standard sigma. But where's the 0.2 go? Well, that goes for the z. It has to do with the z. Now remember, z is always the same thing. It's always the invert normal. My area, my mean, and then my mean estimation is 0 and 1. Right? We don't have it. That's what it's z specifically is always 0, 1. So you gotta find your area. Now the thing is, if you have a node calculator, you decide is this left or right. It is left. It's lessened, so it's the left tail. So for us, it's good to go. Okay, it's like this. 20% is 10, so 0.2. Remember, if you have an older calculator, it doesn't tell you the left or right tail. You gotta make sure it's the left tail. So, like in my calculator I'm gonna use here, I'm gonna use this for my invert normal. So there. Second distribution, invert normal, 0.2. Oops. Remember, we use z, it's always 0, 1 when you use z. Every single time is 0, 1 for z. So negative 0.84162. Now again, I shouldn't round it until I get a final answer. So negative 0.84162. That's what my z equals, and I still have 10 minus that over that. Then just to make it a little nicer, I'm going to multiply both sides by sigma. So I don't have to deal with it. So I'm going to have negative 0.84162 sigma equals 10 minus mu. So something to that effect. Okay, I got to do something over here with this one. Let's do this one in purple. So we're going to use this value. My x is 13 for sure. And my z, just like always, it's invert normal. My area, and then 0, 1. Now in this case, it says greater than 13 so this is, for me, it's going the wrong side because I have the old calculator. So this is going from the right hand side. It's 15% is 13. Now again, if you have an updated calculator, you just do invert normal and just say tails on the right, and you're good. I don't have that, so I gotta always do the left hand side. So for me, I'm gonna plug in 1 minus 0.15, which is 0.85. So that'll be my invert normal. So I put that in my calculator. So second distribution, invert normal, 0.8501 because it's a z. I get 1.03643 equals 13 minus mu over sigma. Okay, just like I did before, I'm going to multiply both sides by sigma so I don't have to deal with it. And we're going to get 1.0364 sigma equals 13 minus mu. So what to do now? Well, I have two equations, two unknowns. You go back to algebra 2. We solve it by elimination or substitution. So I'm going to have this here equals 10 minus mu. And I'm going to have this here equals 13 minus mu. How do I solve this? Well, I would probably multiply the top row by negative 1. So I get 0.84162 sigma equals negative 10 plus mu. When I add them up, the mu's cancel, right? Positive mu, negative mu. Oh, I say mu, sorry, it's mu. So those cancel out and I get negative 10 plus 13 is 3. Over here I get this sigma plus this sigma. I don't know what those are. I'm out of my calculator. So I'm going to get this answer. Ooh. This answer. I'm going to plus it the negative version of this answer because I multiply by negative. I'm being really cautious about like not rounding, but I could just add those two, but be fine. I'm just being extra cautious for no reason. 0.5 like that. And then again, I still want to solve for sigma here. So divide by 1.87. I get sigma equals, so I'm going to get 3 divided by that. 1.57. So again, we round 3 sig figs here because it's an answer. I'm going to round that, so it's be 1.60. Right, so it's a little weird 3 sig fig ones, but 1.60 is my sigma. I still got to find my mu. So how do I do it? You go back to one of the equations. Go back to like this one or this one, doesn't matter. Plug in your sigma. So plug this back into here. So I'm going to get, let's see, that times sigma, and then add the 13, like do the math. Right, so I'm going to multiply this by that. So I have my answer there. Over here, I'm going to multiply that by 1.6. Again, I'm using 1.6, so that is the answer I got. Rounded. So 1.65 is going to be this guy. And then if I add mu to both sides and subtract that from both sides, I'll get my answer. So 13 minus this guy should be my answer. 11.3. So my mean is 11.3. So, right, it's a lot of ugly work. I wish I had more space. I didn't have that much space because I write big. But the general idea is, right, so anytime you're missing a mean or standard deviation, you got to use the normalization formula. Since in this case I'm missing both of them, that's like the worst. This is like the worst possible case. Of all normal problems, this is the worst possible case. You're missing both the mean and standard deviation. So I got to do 2 of them. When you do it and you set it up, z is always found the same way. Z is just invert normal 0, 1. You just got to find the area. In this case, the area is 0.2. So So plug it in, get your value, set up an equation. You gotta do the same thing with the right side because I have 2 of these. So again, how do you find your z? Always the same thing. Invert normal 0, 1. What's your area? I have the old school calculator, so I can't use the 0.15 and say right tail. I gotta always do left tail, so 0.85. Get my thing, find my answer, put them together, and do elimination or substitution, whatever you want to solve. And when I did that one way, I got theta equals 1.6. Then you got to go back and plug it into any one of the equations to find your sigma. In my case, my mu, and I got 11.3. Now they want you to find, using your answers, find the probability greater than 12. Well, that's just a normal problem, right? My mean is 11.3. 12 will be on this side. I want greater than. So it's me 12 to E9. It's me normal CDF 12 to E9, 9. Right, so second distribution, normal. We're going from 12 to E9, 9. My mean, I just found it, is 11.3, 36 figs for the win. And then my standard deviation is 1.6. I hit paste and I get 0.331. Remember 36 figs. Next question. Find A if the probability that x is greater than A is 0.1. So again, look at this problem. They give you the percentage, or the decimal. The probability, I should say. So this is an invert normal, right? You're not looking for probability. You have the probability. You're trying to go backwards. So this is invert normal. So I need my area and I need my mean and my standard deviation. I actually know my mean and standard deviation is these two guys. So things I found. So like that. Now this is greater than. So if I draw it, it starts on the right side. And I go 10%, 0.1. So now again, if you have a new calculator, just plug that in and say right tail. I don't have that luxury. Now bitter. So on this side would be 1 minus 0.1, so 0.9. Just like that. Plug that into my calculator. So distribution invert normal, 0.9, 11.3, and 1.6. Hit enter, and I get my answer, 13.4. So that's the number you have to be. The probability of higher than that is 10%. And that makes sense because remember the mean is 1.3, so mean's in the middle and we're a little bit to the right of it. So that all works. Next problem. The length of a steel rod produced by a machine is normally distributed with a standard deviation of 3 millimeters. So again, notice how they tell you it's normal. All normal problems have to tell you it's normal. So we know standard deviation is 3. It is found that 2% of all rods are less than 25 millimeters long. Find the length of the mean. Find the mean length. So we're looking for the mean. So I know I'm going to have to use the z problem, the normalization formula. Now the key part is right here. You gotta be able to translate this. I found that 2% of all rods are less than 25. So that means the probability that you're less than 25 is 2%. So to write it like that. That's kind of the key to all of this. If you could do this, you probably do the rest. Because all I gotta do is plug in everything else in, right? What's my x? My x is 25. What's my mean? I'm looking for that. What's my standard deviation? 3. So how do I find z? Well, z is always the same thing. It's invert normal of the area and then 0 and 1, right? Specifically, z is always 0, 1 of invert normal. So how do you find my area? Well, it's the 2%. Now you just gotta make sure it's the left side or right side, or if you're looking up that both on your calculator. So in this case, it's less than 25 is 0.02. So left side is the left side, so that's 2%. So for me, it's good. It's on the right side. Well, it's on the correct side, which is the left side. So we have that. All I gotta do is plug this all into my calculator and get an answer. So invert normal, 0.02, 0.1, including the z value. We get negative 2.037. Again, I'm not going to round until I get my actual answer. I could write that on here, but my actual answer, I'm not going to round it until we're there. So we have that. And then it's just a math problem. We're going to times it by 3. Like it's something equals 25 minus mu. It's an ugly mu. Then I'm gonna add mu and subtract that from both sides. So let's do that real quick. So we'll get that, times that by 3. I get negative 6.16. Again, for me, the easiest way, I don't like negative mu, so the easiest way, I like to add mu to both sides and add that to both sides, essentially. So I'll do this. Then plus this to both sides also. That way I get mu equals, so it's going to be 25. I'm going to put negative this because double negative makes it a positive. And I get 31.16. Now again, 3 sig figs, 31.2. So 31.2. So there we go. The next one, random variable x is normally distributed with the mean of 20.5 and the standard deviation of 4.3. Hey, we have both of them. So I don't have to use the z value at all. We just gotta find stuff. Find the probability you're greater than 22. Easy. Normal C. So let me draw it. My mean is 20.5. I want bigger than 22. So 22 to E99. So it's normal CDF. 22 E99. 20.5 and 4.3. Plug this all in. So we're gonna get second distribution right now. Again, notice that it gave us, we don't have the problem. We're looking trying to find it. So it's a normal CDF problem. 22 E99, and then 20.5 and 4.3. And I get 0.363. And again, I'm doing the answer, so I can round it 0.364. 3 sig figs. The next one, they want to go between 18 and 22. So easy. So here is 20.5. So 18 and 22 are like, I guess 18 should be, 22 should be a little bit closer. But those are too, it's so close it doesn't really matter. So it's going to be second normal. We're going to go 18 to 22. Everything else stays the same. And I get 0.356 if I round 3 sig figs. It's about 35%. Next one, k such that the probability of x being less than k is 0.3. Now in this one, notice how they gave you the probability. That's the probability right there. So to go backwards, we're going to do invert normal. So I'm going to draw real quick. Now less than, we start on the left side and 30%. So like that. That's 0.3. That's my k. So I'm going to do invert normal. Remember, if I'm doing it with the old calculator, it has to be left hand side, which is good for me. If you're doing it with the fancy new calculator, it'll let you pick. So 0.3, my mean is 20.5. My standard deviation is 4.3. So I get this. So second distribution, invert normal, 0.3, 20.5, and 4.3. So I get 18.2. Again, does that make sense? Yeah, it's left of the midpoint, and the midpoint is 20.5, so it should be less than it. So there's that one. The IQ of students at a school are normally distributed with a standard deviation of 15. If 20% of the students have an IQ higher than 25, that's very good actually. Find the mean IQ of students at the school. So again, we're looking for the mean. We don't have the mean. So, which means if I'm missing something, I have to use this formula. If I'm missing it, I have to normalize it. So I'm going to use that. Now the key thing I always say is this part right here. If 20% of the students have an IQ higher than 25, find the mean. So that's the key. You gotta write that. So that's saying the probability that x is greater than 125 is 0.2. Right? So that's what I'm putting into here. So let's plug in what we know. I know the standard deviation is 15. I know x is 125. And then my z, remember, we always find out the same way. It's invert normal, my area, and then 0, 1. So z is always specifically 0, 1. Now in this case, I can't use 0.2 because I don't have a fancy new calculator that lets me do left and right tail. So I have to figure out what the other side is, because this is what I have right now is this. Because greater than starts on the right hand side, and that is 0.2. So I need the left hand side, which in this case will be 0.8. So to use 0.8 because my calculator's old. So let's type that all in there. So second invert distribution, invert normal, 0.8, and then 0.1. Hit enter, I get 0.8162. Something like that. So I'm going to rewrite this 0.8162 equals 125 minus mu over 15. Then let's solve it, right? Multiply both sides by 15, add mu, subtract that, blah, blah, blah. So let's do it right now. So I'm going to get that. Again, I'm going to leave it. I'm not going to use it around it until I get my final answer. So I'm going to leave that there and times by 15. And I get that 12 point. I'm going to put 12.6 just for us. Equals 125 minus mu. And again, I would add mu to both sides and subtract 12.6. So I would get 125 minus 12.6 with stuff. And I get 112.37, 3 sig figs, 112. So there we go. That's a nice mean. Next one, the distance an athlete jumps are normally with a mean of 5.2. If 50% of the jumps by this athlete are less than 5 millimeters, what is the standard deviation? So now we're missing a standard deviation. But it's essentially the same problem, right? I'm missing something, so I gotta use this formula. Like that. My mean is 5.2. The key thing is you gotta be able to rewrite this guy right here. So what does it say? If 50% of the jumps by an athlete are less than 5 millimeters. So probability that you're less than 5 millimeters on your jump is equal to 0.15. Just like that. Right? What's my x? My x is 5. Z is always the same thing, invert normal. My area is 0, 1. This is less than, so I know it's going the right way. I could draw it just to make sure though. Right, this is 0.15. Is that 5? So I can just plug it in. Nice, if I plug it into my calculator. Distribution, invert normal, 0.15. And I get negative 1.0364. Remember, I'm going to write that here. But I'm going to leave it on my calculator until I get my final answer. So let's rewrite that to make it look nicer. Okay, so I get that. I would multiply both sides by sigma. So negative 1.036 sigma equals 5 minus 5.2, so negative 0.2. Then we just got to divide by that. And then sigma equals, again, my calculator, I'm not going to round it. Well, not until I get my final answer. So I'm going to do negative 0.2 divided by my answer right here. And I get 0.193 if I round it correctly. Right, you only want to round the final out to 3 sig figs. Something like that. So that's the standard deviation. Next one. The weight of an apple in an apple harvest is normally distributed with the mean of 300 and a standard deviation of 50. Only apples with weights between 250 and 350 are considered fit for sale. Find the proportion of apples that are fit for sale. So notice again how we have the mean and standard deviation. So this is not like a z problem. We have the mean and standard deviation. It just wants to know, hey, what's the odds are fit for sale? So what's between 250 and 350? Here's 300. It's between 250 and 350. So A is a normal CDF question. It's a normal CDF. Lower bound's 250. Lower bound's 350. My mean is 300 and my standard deviation is 50. Right? Once you have both of them, then it's one of the easier ones. You just do, it's either this or the invert normal one. So second distribution, normal CDF. And it's between 250, 350, standard 350. It's probably gonna be like 68%, something like that. 0.682 something. I got some game. 0.682689. If I was doing this, 36 figs, so 683. So like that. B, in a sample of 100 apples, was probably that at least 75 are fit for sale. So now look at this question. It's a different type of question. In a sample of 100, right there it tells me binomial. This is a binomial question. So the binomial question, it wants to probably that at least 75. So remember I was thinking about it like at least 75 cookies. That's my low end. So that's that. Binomial of x greater than 75. Now remember binomial, it cannot be greater than. Normal doesn't give a crap. Binomial does. Has to be less than or equal to. Doesn't matter what calculator you have. Has to be less than or equal to. So you gotta change, it's pointing the wrong direction. So to fix the point wrong direction, you do 1 minus the complement. So you switch that. So that'd be x less than 75. Right? Since it has greater than or equal to sign, when you switch it, it loses it. If it didn't have it, you'd gain it. And then I can't have a less than sign, it has to be less than or equal to, so you gotta go down 1. So 1 minus x is less than or equal to 74. So I'm gonna put this in my calculator. It's gonna say binomial. It's gonna want the number of trials, n, the probability, and then the r. Number of trials is 100. Probability is what we just found. Classic IB, 0.683. That's a probability that's fit for sale. And then r is gonna be 74. So for my calculator, I'm gonna do 1 minus. I always like to do that first, for don't forget. Second distribution. Binomial is toward the bottom. CDF, because it's less than or equal to. Trials is 100. Probability is 0.683. Since we're using an answer from before, we use the rounded version. And then I'm going to put 74 here. I get my answer, and I get 0.0894. So 3 sig figs would be 0.0894. Exactly what I said. So like that. Next one. The height of an 18-year-old boy is never true to the mean of 187. 15% of 18-year-old boys have heights greater than 193. Find probably that 2 18-year-old boys chosen at random will have heights greater than 185. So there's actually a surprising lot going on here. So we know 50% of 18-year-old boys have a height greater than 193. So I don't know what the percentage of them have a height greater than 185. So the way you normally do this would be normal CDF 185 to E99. That's the problem though. I don't have the standard deviation. So I got to find the standard deviation first, and then go back and plug that in here to find the probability that you're greater than 185. Then on top of that, I'm going to pick 2 of them. So I got to multiply by itself. It was like, what's the odds of getting 1? What's the odds of getting 2? Just multiply 2 in a row. So I have to do all that. And now I'm looking at why it gave so little room. So let's just start with the first part, right? I got to find the standard deviation because I'm missing it. So what do we have? We have a mean of 187. So I'm missing something. First, let me go back to that. I'm missing something, so you have to go back and find this. And then what do we have? We have the mean is 187. We know that 15% of 18-year-old boys have a height greater than 193. So again, you have to know how to rewrite that. So we're saying the probability you're greater than 193 is 0.15. So it's all about how you rewrite that. So when I go in here, my x is 193. Z is always the same thing. It's invert normal of the area, which we got to talk about, and then 0, 1. Z is always, always, always that. So what's my area here? Again, if you have a new calculator, this is greater than, so it's going on the right-hand side. It's a right tail, 0.15. I don't have a new calculator, so if I was to draw it, it would be like this. I can't use that side, I got to find this side. So that's be 1 minus 0.15, which would be 0.85. So 0.85 goes there. Plug this into the calculator, set it equal to that. So I need invert normal of 0.85. And I get 1.0364. So 1.0364 equals 193 minus 187 over phi. As always, I like to multiply it and then do some math. So let's multiply by sigma. So 10364 sigma equals 6. And then all we gotta do here is 6 divided by that. So 6 divided by, now again, use the answer, don't just round it yet, until you get an answer. And I get 5.789 something. So that's equal about 5.79. That's my standard deviation. That right there. Okay, now that I have that, now I can find the probability that you will have a height greater than 85. Like I said, I'm plugging into here. Now we figure out what the standard deviation is. You can plug it into this equation to find out the probability you're greater than 185. So I have to go back here, do a normal CDF, second distribution. Normal CDF problem, I'm going to be on what's probably higher than, taller than 185. Upper is E99. Mean is 187, and then we just found the standard deviation, which was 5.79. And I get 0.6351178. Now again, this was solved picking two kids like that. So one at final step, multiply this by itself. Because I'm going to pick two kids like that. So odds of getting one is this. Odds of picking another one, just multiply by that again, same odds. And you get that. So 0.403 if I round to 3 significance. So about 40% chance. There's that one. Next one. The diameter of pistons manufactured by a company are normally distributed. Only those pistons whose diameter is between 3994 and 4.06 are acceptable. Find the mean standard deviation. Oh man, to find both of them. That's the worst, like the worst out problem. If 4% of pistons are rejected as being too small, and 5% are rejected for being too large. So this is like a good like IB exam question one. So they tell you something that, hey, only ones between this and this are acceptable. So you're only good if you're between those two. Now, and then it tells you that anything less than where am I at? So 4% are rejected for being too small. So tell me right now that this right here is 0.04, and then too large is 0.05. So they gave me everything just like not directly. So we're missing mean and standard deviation. So remember what that means? We have to do this twice. I have to do one for mean. I have to do one for standard deviation. Well, not directly. You have them both missing in both equations. But you have to do two of them. So I guess let's start with the small side. 4% piston rejected too small. So what does that? How do I translate that? The probability that you're less than what? Too small will be 0.3994 is 0.04. So I'm gonna plug that in, everything I know in, right? Which is only x and z. X is 0.3994, and then z is always the same thing. Invert normal. My area is 0.04. Mean 0 and 1, right? Anytime I do z, my mean and standard deviation is 0 and 1. So I gotta plug that in and plug into the equation. So invert normal, 0.04, 0, 1, blah, blah, hit enter, and I get negative 1.75. So into that effect. Again, I'm gonna set this equal to what I know, 3.994 minus mu over phi. I like to get one of these by themselves, so I'm going to move that over. So negative 1.751 sigma equals 3.994 minus mu. So I get something like that. Now again, this is if you want to do substitution, it's actually very easy. Just add this, subtract that, and then you get what u is, and you plug into the other equation. Speaking of which, let's do the other equation. So now I'm going to do too large. Well, right here it says the probability you're greater than 4.006 is 0.05. The one problem with that's on the wrong side. And again, if you have an updated calculator, easy. I don't, so I gotta use the left side. So for me, I'm using I'm gonna do, when I do my z, my area is gonna be 0.95 because that's the left side. So let's plug it all in. Whoops. So I'll plug this in. This is gonna be 4.006. My z would be invert normal, 0.9501, and that's going to turn out to be 1.6448. Okay, so that's set up also. So 1.6448 equals 4.006 minus mu over sigma. Same idea, multiply by sigma, you're going to get this. 1.6448 sigma equals 4.006 minus mu. Now I got to solve this. I got to have two equations to know, so I got to solve it. Let me put this guy over there. So it'll be negative, whoops, sorry, not negative. 1.6448 sigma equals 4.006 minus mu. So I get that. Then elimination, I'll do that. Multiply the top row by negative. So I get positive 1.751 sigma equals negative 3.994 plus mu. So when you add them up, these cancel. And I get this plus this, that plus that. So that what am I going to get? I'm going to get this guy plus, I'm putting negative, double negative to make it positive, plus this guy. Again, I did double negatives just to make it work out. So I get 3.39553 sigma equals, then I get 4.06006 minus 3.994 0.012. Then all I gotta do is divide that by this guy. By this guy. And I get my answer. So sigma equals 0.00353. Something like that. 3 sig figs. Now that's sigma, I gotta find mu. So remember, the way you do that is you plug it back in. So I plug it back into there. So I'm going to do is get this, multiply by that, and then subtract that from 4.6. So I'll use it on the calculator. Look, we have it. So I'm going to plug this into there. So I have that answer somewhere, don't I? There you go. Multiply that by 0.00353. And I get this. So this is like 0.005806 equals 4.006 minus mu. Again, I like to add mu and subtract that. So I'm going to get 4.006 minus my answer. And I get mu equals essentially 4. 3 sig figs, so 4. And there you go. That was ugly. Next one, this is still part of the same problem, so it's like part B. Determine the probability that the diameter of a roundly chosen piston lies between 394 and 4.03. So now they want the probability that this happens. So remember, that's a normal CDF problem. And we just found everything. This is 3.997. This is 4.003. This is, my mu is 4. My standard deviation is this. So we just plug that all into our calculator. And this disgusting problem is over. So normal CDF 3.997, 4.003, 4, and 0.00353. Plug it in, you get 0.604596, 3 sig figs, 0.605. So there you go. There's that one. One more page left. It's like a practice quiz one, I think. Yeah. Okay. So weight of cows is normally distributed with a mean of 1,500 pounds. And with the standard deviation of 75 pounds. Hey, I give you both. Find probably that Randy says a cow weighs more than 1,400 pounds. Okay. So the mean is 1,500. And then we want more than 1,400. So over here somewhere. And I want more than that. So I'm going to go 1,400 to E99. This is a normal CDF problem. Just straight out, what's the probability? I write this because this is what it looks like on the calculator. I don't think I'd be really expecting to write that, but I do that because it's to show you what it looks like on the calculator. So second distribution, normal CDF, 1400, E99, 1500, 75. So 0.90878, or again, 3 sig figs, 0.909. So you get that one. If 12% of cows weigh more than K pounds, find probability K. So now again, notice that they give us a percentage. They're essentially saying f of x is greater than K equals 0.12. Like that's what that's saying. So I like to draw it. So greater than start on the right hand side, and you go 12% back from there. So this is 0.12. There's my K. Now again, if I had a fancy calculator, it would be invert normal 0.12 right tail. I don't have that. I need the left side. So to find this left side, you do 1 minus 0.12. So I get 0.88. So it's going to be invert normal 0.88. My mean is 1500. My standard deviation is 75. Plug that all in. And we get 0.88. I thought I hit enter. 1500. 75. 1588. Again, 3 sig figs. It's 3 sig is kind of like if it's decimal stuff. Like if in this case it's 0.1588, it's fine. If 20 cows are selected at random, find probably exactly 5 of them weigh K pounds. So again, I just figured out what K was. So weigh 1588. So if 20 cows are selected, find probably exactly 5 of them weigh K pounds. So exactly 520 cows selected is a binomial problem. Binomial PDF this time because it said exactly. So all we need is NPR. Exactly 5 of them, so that's easy. So the number is 20. Probability, it's K pounds, which is 1588, but what's the probability of that? 12%. So 0.12, and I want exactly 5. So it's the binomial PDF of that stuff. PDF's the easy one because it says exactly, so that's a lot easier. So second distribution, binomial PDF, 20, 0.12, and 5. And I get 0.0567. 3 sig figs perfectly. So you get that. D, if the weight of bulls not cows this time, or no with the mean is 1700. If 30% of bulls weighed less than 1657, find the standard deviation. So we're missing the standard deviation. Luckily, we're only missing one. And remember, when you're missing one of the two, you got to do the z value. So z equals x minus mu over phi over sigma. Sorry. What do we know? We know the mean is 1700. We know that 30% of bulls weighed less than 1657. So again, we got to know how to translate that. So the probability you're less than 1657 is 0.3. So that means my x is 1657, and my z is always the same thing. Invert normal. Area 0.1 is just going. It is less than, so I can just plug in 0.3. Right? If I was to graph this, it'll be on the left hand side. So we can just plug it into our older new calculators and just have our answer. So now let's simplify that. Plug it into your calculator. So second distribution, invert normal, 0.03, 0.3, sorry, not 0.03, I almost said 3%, it's 30%. There we go. Everything else is fine. So I get negative 152. So negative 0.5244 equals 11657 minus 1700 all over mu. As always, I like to multiply both sides by sigma. I keep on saying mu. that's sigma equals, what is that, 43? Negative 43. Right, 1657 minus that, negative 43, and then we just divide by that. So negative 43 divided by this, and I get sigma equals 81.9983, or 3 sig figs 81.0. So that's the standard deviation, 82, sorry. That's how you round that. There we go. Found probability is that roundly selected bowl weights between 1680 and 1720. So they just want to find the normal CDF value between these two values. Right, well, my lower bound to be 1680, my upper bound is 1720. My mean, they tell us, was 1700. And my standard deviation I just found is 82. So let's plug that. It's the normal CDF problem with all that information in there. So second distribution, normal CDF, lower bound is 1680, upper bound is 1720, mean is 1700, standard deviation is 82. My answer is 19.26, so 1.19336 figs. There we go. That's the lesson. Worksheet.